All right, before you dig into this video, if you have not read the section that is marked there between those braces, please stop the video and take the time to read that through a couple of times, as that is the information we're going to use to continue on with this section of notes. Now, the key to solving problems like we're going to be working on is to first of all, understand very clearly what all of those words mean. So we're going to walk through this here bit by bit by bit to make sure we understand what's going on. So when it says a disease has an incidence rate of 0.5%, that means the disease afflicts 0.5 or 1/2% of the population. So what we're going to do is we're going to write that percentage as a decimal. And just as a reminder, what you're going to do is move the decimal 2 places to the left in order to turn our percentage into decimal form. So when we move that 2 places to the left, we end up with 0.005. So that means the probability that someone in the population has the disease is 0.005. The test does not produce false negatives. So what that means is that if someone has the disease, they're going to test positive, okay? There's no way that they're going to have the disease and then take a test and be told that they don't have the disease, all right? So that means the probability that the person tests positive, given they have the disease, is 1. It's absolutely guaranteed if they have the disease, they will test positive for the disease. All right, the false positive rate is 7%. So that means that 7% of the people who take the test are going to have a positive test result even though they actually don't have this disease. So the probability that they test positive, given that they're not diseased, they don't have this disease, is 0.07. That's the 7%, again, written in decimal form. Move the decimal 2 spaces to the left. So what we're going to do is we're going to say we select 10,000 people at random. The 10,000 is a number that I made up. You can pick whatever number you want. I would recommend 10,000 or 100,000 if you're going to create these tables on your own. So let's say out of these 10,000 people, how many of these 10,000 people have the disease? Well, we need to find 0.5% of 10,000. And the way we calculate that is we write the percent in decimal form, so 0.005, and we multiply it by those 10,000 people, and we will find that 50 of them are expected to have the disease. Out of those 10,000 people, it means that the other 9,950 of them do not have the disease. So what I'm going to do now is I'm going to take those 2 numbers and I'm going to put them in the table. So out of this total 10,000 people, we know 50 total people will have the disease. The other 9,950 people should not have the disease. All right, of those who do not have this disease, 7% of them are going to test positive. So we want to find 7% of those 9,950 people, because again, they do not have the disease. Of these, 7% will test positive. So to calculate that, write 7% as a decimal, multiply by the 9,950 people, and that will give us 696.5. Now, I know we're talking about people, but please don't round, okay? Go ahead and use the decimal form. It's perfectly fine. Had you taken this to 100,000 people, we wouldn't have gotten a decimal in this case. So, of those who do not have the disease, so again, we're still in this column here that I've got all the arrows pointed to, 696.5 will not have the disease, okay? In order to find this number here in the test negative category, notice that the number who test positive plus the number who test negative should total that 9,950. So subtracting will get us a total of 9,253.5 that have a negative test result. Now remember, when they have the disease, so now looking at this column here that I'm marking with stars, every single one of them, if they have the disease, they will test positive. So all 50 of those people are going to test positive. No one will end up with a negative test. And then we can find the totals in that last column by simply adding the numbers in each row. So 50 plus 696.5 is 746.5, and obviously 0 is easy to add to 9,253.5. And you can double check that those two numbers that we just wrote in really truly do add to 10,000. Now, what are we going to do with this information? How many people tested positive for the disease? Okay, how many tested positive? So I'm going to switch colors here. That is this number right here. That's those 746.5. It is the combination of the 50 who actually have the disease, along with those people who tested positive, even though they don't have the disease. So the probability that the person has the disease, given that they tested positive, okay? So again, all of the total people who tested positive are these 746.5 people. Okay, and out of those, 50 of them actually do have the disease, which works out to be 0.067 as a rounded decimal. So what that means is that of all of those positive tests that happened, only about 6.7% of them actually have the disease, okay? On the other hand, of everybody that tests positive, that means that 100% minus the 6.7%, or 93.3% of these people don't actually have the disease, okay? So when it talks about false positives and false negatives, and this is very much a real world scenario, okay? We're living in COVID right now. How many false positives and false negative tests are out there? There's a whole bunch, okay? But in this case, whatever this disease is testing for, even if you would test positive for it, there's still a 93.3% chance you don't have this disease. Okay, in the next section or the next example, we're going to be looking at further examples of this, and I'm going to slowly start to take away some of the scaffolding so that you can start to reason through these same scenarios on your own.